Okay, let's get started. So the goal today is just to go over Taylor series. Um, I mean, it looks difficult, but really it's just like one formula. And after that, I'll just leave the discussion for any last minute questions. So, I mean, I hope you all know, but your final is next week, Monday. So, okay, so Taylor series are just functions that equal their power series. So they have a power series expansion. And then Maclaurin series, you could think of these as series centered at zero. For the majority of the time, we've had power series centered at zero. So if F has a power series, but you can certainly center it at elsewhere, series expansion. Centered at A, i.e. like F of X is equal to this power series, right? So I'm sure you are all used to this, right? So you're used to A being zero, right? Cn x to the n, but certainly, you don't need it to be centered at zero. So this is R, the radius of convergence. Then Taylor actually found out that the coefficients are given by a formula. Given by Cn is Fn at A over n factorial. Yeah. So Taylor series seems really hard, but really it's just this formula and this. If you memorize this and this, you're pretty much good with it. I mean, along with the known Maclaurin series that I will write in the next page. But really, this is all there is to it. So basically, there's a way to find what these coefficients are. It's related to the derivative. So this is like the nth derivative, right? Again, we write the nth. We write it like this because I know. I mean, like I'm sure you would rather write this than this, right? I mean, f prime is okay, right? F prime, but like once you reach the fifth derivative, you're not gonna write prime, right? So we go with like f. We go number to denote the derivative. Okay, so again, if you like, this is for it. And then another way to think of it is like, i.e., A is zero. Yeah. So Maclaurin series are just Taylor series centered at zero. So there are known Maclaurin series. These I suggest you just memorize. Like, that was ugly. So you have the famous one, right? The geometric series, sum n equals 0 to infinity, x to the n. Radius of convergence is obviously 1. Right? And e to the x is given by x to the n over n factorial. And this is radius of convergence is infinite. And you have your famous sine cosine functions. Sine, I mean, once you memorize sine, you've memorized cosine, because sine are like the odd terms, cosine are like the even terms. So it's x minus x cubed over 3. By odd terms, I mean like odd power, right? But I actually didn't copy all of the radius of convergence, so my bad. But it's in your book. x squared over 2 factorial plus x to the 4th over 4 factorial. So again, cosine's the even ones, right? So I'm just going to write 2 more. 10 inverse of x. And I'll show you how to, if you forget, you can always derive. But you don't want to waste time on your test deriving. So I really suggest you just memorize these. N minus 1. Okay, so and then the rest of the charts. But the important thing is, have you ever wondered, like, I don't know, if you typed in sine of like 1, have you ever like wondered like how the calculator calculates that? Certainly, if you were to make a calculator yourself, you're not going to tell the calculator, hey, memorize sine of 1, then memorize sine of 2. And then, there's just infinitely many numbers, right? You can't do it that way. Okay, you can't tell a calculator to just memorize sine of 1, 1.1, 1.0001, like that. That's just impossible, right? So what the calculator does instead is they take this equation and they plug in 1, and then they stop at like, I don't know, the x to the 99 term. Yeah. And that would give a very close, a good enough approximation. At least up to the, I don't know, 20th digit or something, that of what sine of 1 is. So when you type sine of 1, what the calculator is actually doing is calculating this. It's calculating 1 minus 1 over 3 factorial plus 1 over 5 factorial minus 1 over 7 factorial, so on and so forth. Yeah. Same thing here, right? If you wanted to know the value of e, well, e is just e to the 1. And so this is like 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial to the dot. Yeah. And obviously, you can only do this within the radius of convergence, right? So here it's infinite. So really, it's for any number. Here, if you checked it for like 2, it would not work. Yeah. You can only check for numbers between 0, -1, and 1, right? Because the radius of convergence is 1. Is everyone clear on this? Okay. So let's see how they got this, right? I'm just going to choose sine x. Right, so remember, we are centered at 0. So this is a is 0. So c0 plus c1x plus c2x squared, c3x cubed, c4x to the 4th, so on and so forth, right? 5th. Right? So we want to express sine x as this. Well, we have a formula. Cn is Fn. In this case, we're centered at 0, so a is 0, over n factorial. So let's calculate it. F of x is sine x. What is the derivative of sine? And just moving on, right? Derivative cosine is negative sine. Negative sine is negative cosine. Derivative of negative cosine is sine. And then so on and so forth, right? Let's just stop here. So now we want f at 0. So f of 0 is sine of 0 is 0. f1 at 0 is cosine of 0. So cosine of 0 is 1. f2 at 0 is 0 because sine of 0 is 0. f3 at 0 is negative cosine of 0. That's negative 1. f4 at 0 is 0. And f5 of 0 is 1, right? And now let's figure out C0. C0 is f of 0 divided by 0 factorial. I'm using this formula. F of 0 is 0, so it's 0. C1 is f1 at 0 divided by 1 factorial. So that's 1. C2 is f2 at 0 divided by 2 factorial. So that's 0. C3 is f3 at 0 divided by 3 factorial. What's 3 factorial? 3 factorial is, f3 is -1. But 3 factorial is 3 times 2 times 1, right? So that's -1/6. But we will just leave it as 3 factorial for now, because that's how the book kept it. So, but just keep in mind, the 3 factorial is just 3 times 2 times 1. C4 is 0, right? Because f4 at 0 is 0. And C5 is f5 at 0 divided by 5 factorial. So this is just 1/5 factorial. So we could write it, right? C0 is 0, that's gone. Plus C1x, so it's x, right? C2 is 0, so that's gone. C3 is -1/3 factorial times x cubed. C4 is gone, right? Because C4 is 0. C5, the coefficient C5 is 1/5 factorial. So on and so forth, right? So we found the first 3 non-zero terms. And guess what? That's exactly what it is, right? We just got this. So I mean, all they did was they found the pattern, and then they just wrote it as a series, right? I mean, you can see the pattern too, right? Denominators going up by as in odd numbers, so it's every odd number. So to indicate an odd number, you would do 2n plus 1, right? And then the powers match, so this is 2n plus 1. And then you alternate sign, so you have a -1 to the n. So really all they did was they figured out the pattern, so they don't need to take derivatives anymore. I mean, eventually it repeats, right? At this point, it just repeats. So that's how they get the formula. Is what I'm trying to say. Okay, let's do another example. So use Taylor series to find first 4 non-zero terms centered at A. And let's do f of x is ln x, and let's take A to be 1. Again, write out your formula. It's x minus a to the n, right? A is 1 in this case. So I want to express natural log as this. I mean, right, so on and so forth. But the idea is, I mean, unless you find the pattern like sine, it's really hard. So that's why they only ask you for like the first 4 non-zero terms. So let's do it. So same idea, right? Cn is Fn at A, which is 1 in L. The previous one was Fn at 0 because we were centered at 0. Now they want you centered at 1. So it's Fn at 1. Okay, f of x is natural log. The derivative of natural log is 1/x. So it's this. I mean, hopefully you know by now it's power rule. Let's take derivatives. What is that? -6x and -4? Yeah. And I mean, at this point, you just, f of 1 is 0. f1 at 1 is, well, 1 to any power is just 1. So we'll use that to our advantage. Is -1. Yeah. And then we could find our C zeros. So again, like I said, everything is this formula and this formula. That's really all you need to know. So C0 is, again, I'll write it out, is f of 1 over 0 factorial. Again, 0 factorial by convention, it's 1. Yeah. So it's 0. But I mean, that could, and then C1 is f1 at 1 over 1 factorial. That's 1. C2 is f2 at 1 over 2 factorial. F2 at 1 is -1. So 2 factorial is 2. So it's this. C3 is f3 at 1 over 3 factorial. So what is that? That's 2. And then 3 factorial is 3 times 2 times 1. So that's 6. So that's 1/3. And then C4 is f4 at 1 over 4 factorial. Well, 4 factorial is 4 times 3 times 2 times 1. That's 24. So, I mean, natural log, at least for the first, it's 0, C0, 0. C1 is 1, so it's just x minus 1. C2 is -1/2, so. And then C3 is 1/3. Plus C4 is -1/4. And of course, you can continue to find C5, C6, but the point is we found the first 4 non-zero terms. The first term is x minus 1. The second term is this. Yeah, keyword non-zero. If it didn't say non-zero, you would include the C0, which was 0. But yeah. And then your next one's 1/3 x minus 1 cubed. Then your next one's -1/4 x minus 1 to the 4th. So these are your your first 4 non-zero terms. Is everyone clear on this? Yes, no? Okay. So let's do one more. So this one, you have to find the actual Taylor series, but you're gonna see that unless it's like the sine one where you have to find a pattern, this one you actually don't need to because it's a polynomial centered at A. So we want the whole Taylor series. So we want like Cn all the way to C infinity, right? So if you want to think of it that way. Plus x, and I want it at A equals 2. So before we do this question, the question wants you to express f as a Taylor series centered at 2. I'm saying this is already a Taylor series, but it's not centered at 2, it's centered at what? This polynomial here, centered at what number? Again, let me remind you, centered at A means this, right? So they want you to choose A to be 2, but what is this thing already? I'm claiming this thing is a Taylor series, but it's centered at what? I mean, if you had to have a guess, What would you guess? So if it was centered at 2, everything would be like x minus something, x minus 2 to some power. That is certainly not the case here. I mean, you don't see any x minus 2 to the fifths, right? You only see an x to the fifth. So what do you think this is centered at? Yeah, 0, right? So let me just convince you all. If a is 0, then this is just cn x to the n. And this is c0 plus c1x plus c2x squared. Right? So on and so forth, right? And this thing is just this with what's the coefficient of x? C1 is 1. What's the coefficient of x cubed? It's 2. And the coefficient of x to the fifth is 1. And then you have C2, C4, C6, C7, C8. Everything else, right, is 0. Yeah. So this is just a Taylor series centered at 0, right? The question wants you to recenter it. The question wants you to write f of x as, I mean, these c's are different, by the way, but, the question wants you to write it as sum n equals 0 to infinity. So they want you to write it as a0 or not a0, c0 plus c1x minus 2 plus c2x minus 2 squared. So on and so forth, right? So does everyone understand the question? So they want you to recenter it at 2. Okay. Knowing that, let's do the question now. Same exact thing, right? Like you just do derivatives. Except they want the whole Taylor series, so we're going to have to keep doing derivatives until we see a pattern. So let's start. f1 at x is 5x to the 4th plus 6x squared plus 1. f2 of x is 20x cubed plus 12x. f3 of x is 60x squared plus 12. f4 of x is 120x. f5 of x is 120. Can anyone tell me from here what f6 of x, f7 of x, f8 of x, what everything on afterwards is? Because if f5 is 120, f6 is derivative of 120. So what's derivative of 120? So f6 is 0. And then f7 is derivative of f6. f7 is derivative of 0, which is 0. f8 is derivative of f7, which is 0. So these are all 0, right? But if that's the case, then c6, right? Let's do c6, for example. This is f6 at 2, right? Over 6 factorial. I don't care what this is because f6 is 0, right? This is 0. Similarly, f7 is 0. So this thing is just 0. So you're going to see that c6, c7, c8, everything onwards is just 0, right? So really, we only care about the first 5, which makes sense because our polynomial is degree 5. Okay. So let me erase this. So now we only care about the first 5s, or I guess first 6, because you have f. So f of 2 is 32 plus 16 plus 2, so it's 50. f1 at 2, or f prime at 2, is, what is that? 5 times 16 plus 24 plus 1. What is that? 105. F2 at 2 is 2 cubed, so 20 times 8 plus 24. 160 plus 24 is 184. F3 at 2 is what? 2 squared, 240 plus 12, 252. F4 at 2 is 240. F5 at 2 is 120. And now it's the same thing, same formula. Cn, let me just write here, Cn is Fn at 2 divided by n factorial, right? So C0 is f of 2 divided by 0 factorial, so that's 50, because 0 factorial is by convention is 1. C1 is f1 at 2 divided by 1 factorial. So this is just 105. Whoa, what did I do? It's 50. C2 is f2 at 2 divided by 2 factorial. Well, f2 is 184. 2 factorial is just 2 times 1, so that's 2. That's 92. C3 is f3 at 2 divided by 3 factorial. Well, f3 is 252. 3 factorial is what? It's 3 times 2 times 1. 3 times 2 times 1 is 6. Yeah, and you're going to get this, what, 43? Is it 43? No, it's not 43. It's, is it 43 or 42? Let me think. Yeah, 42. Huh, okay. C4 is f4 at 2 over 4 factorial. So f4 is 240. And what is 4 factorial? 4 factorial is 4 times 3 times 2 times 1. So that's 24. This is 10. And then C5 is F5 at 2 over 5 factorial. 120, well, what's 5 factorial? 5 factorial is 5 times 4 times 3 times 2 times 1. That's actually 120. This is just 1. You are done. So for Taylor series, because I mean, like we said, C6 and everything else was 0, right? So f of x is actually 50 plus 105 x minus 2 plus 92 x minus 2 squared plus plus what's C3? 42 x minus 2 cubed plus 40. No, what's 10 x minus 2 to the 4th plus x minus 2 to the 5th. And if you really wanted to check your work, you can FOIL all this and you should get this. Yeah. The goal of the problem was to recenter at 2. Is everyone clear on this? So like I said, Taylor series is not that bad. It's just this formula, right? Once you know this formula, you just plug in and do algebra. Okay. I'm gonna end with this. So do you all remember that what I told you, like series that we know, I'm just gonna give you advice, series that we know what it converges to, if it converges. Or there's actually just 3 types, right? There's geometric, right? So if it converged, then it's A over 1 minus R, right? There's telescoping, in which stuff cancels out, if you remember. And the third one is the Taylor series chart. That's really the only three, right, that you know. So my advice is, you know, if on the final, if it's exactly written as this, exactly written as follows. So if the question is something like determine whether series converges or diverges, and then they add a second part. So if series converges, determine what it converges to. It's this part that tells you one thing. So if it tells you that, so I'm saying if it's none of these, if it's none of these three, the series diverges. If this is how the question is written, because the only type of series that you know exactly what number it goes to is these three. Yeah. If it didn't have the second part, anything's fair game, right? Like, I mean, at that point, there's nothing you could do except use your tests. Like, so like stuff like integral tests, comparison tests, alternating series tests, like those tell you whether it converges or diverges, but I mean, or just converge, right? But it doesn't tell you what it converges to. It doesn't tell you what number it converges to. So if they ask you what number it converges to, it can only be like one of these three, right? So the only ones they can give you that converge are these, either this geometric telescoping or Taylor series chart, right? So let me just, you know, example, a Taylor series chart, I mean, like, you know, if they ask you whether this converged or not, yeah, and you can use ratio tests to like show it converges, but then the question is, you know, what does it converge to? Well, does this, is this geometric? Probably not. There's a factorial there. Yeah. Is this telescoping? Terms don't really cancel out, so no. So then you just ask, is this in the Taylor series chart? And sure enough, it is. Like, if you look at cosine, it's -1 to the n, x to the 2n over 2n factorial. So let me just write that again. So cosine of x is sum n equals 0 to infinity, -1 to the n, x to the 2n over 2n factorial. So if you just match it, what is this? Well, this is just cosine of pi, right? If I plug in x equals pi, I get exactly this. And what's cosine of pi? It's -1. So this thing is actually just -1. So everyone clear on this? Gonna stop recording.